Hello and welcome to this very special webinar by Siemens, powered by Energy Connect. The topic for this webinar today, as you know, is Beyond the Hype, harnessing the power of the industrial metaverse in energy. So what does that mean? Now, among the various emerging metaverse areas, the industrial metaverse offers a unique opportunity for businesses to transform how they design, manufacture, and interact with physical machines, factories, and even grids. And today's webinar will dive deep into this latest trend sweeping the energy sector. A bonus addition during the course of this webinar, you will also get to learn exactly how many zettabytes, yes, zettabytes, of data will be created and consumed globally. This session will cut through the hype to explore how industrial metaverse is poised to transform the energy sector. And to do that, I'm delighted to welcome our industrial leaders from Siemens today. John Nixon, the Vice President, Global Strategy for Energy, Chemicals, and Infrastructure, and Ruan van der Mauwe, the Portfolio Development Executive. Thank you both for joining us today.
Hey, glad to be here. Thank you for having us, CS. This is wonderful. And Ruan, you're in South Africa, and I'm in Seattle, Washington today. So I don't know if we could be farther apart on the globe today. So this is wonderful.
Still good. It feels like very close to you, so.
Yeah. So, all right. So I want to go ahead and get started here, CS, if that's all right. We're going to get moving here. So
absolutely, John. But before we get going, just a couple of housekeeping points. We have more than 850 people who have registered to watch this exciting webinar today. You can always ask your questions in the chat box below. You can post your questions, and John and Ruan will do their best to get back to you once we are towards the end of this webinar after the presentation. We will also have some interaction with our audience today through some poll questions that will show up on your screen. You can type in or choose your responses as you get them, and watch out for more. Yeah, over to you, John.
Okay, thanks, CS. So everybody, thank you for joining us from all points around the globe, early in the day or late in the night. What we want to talk about here with the industrial metaverse, you may recall that in the first week of January of this year at the Consumer Electronics Show, Roland Bush, our CEO, got up on stage and talked about the industrial metaverse. And it was very exciting. It's a very exciting discussion. And for us in energy, it is time now for us to have this conversation more than ever. But real quick, before we get started here, we wanted to do a quick poll of everybody that's on here. So if you could, what is the first word that comes to mind when you hear the term metaverse? And CS, is the poll up where people can actually enter the keywords?
Yes, so you can now see on your screen as you go along, and please do enter your inputs.
Excellent.
Yes. That, John. I mean, the real reason why we are also asking this poll is we are going to talk about a term that's being used across many industries, and from consumer all the way to industrial. And I think what we need to understand, we are going on a journey in the next, let's say, 45 minutes, and we need to understand where are people starting off of. And so that we can also marry that at the end of the day to where have we come after the session. So
that's
gives us some good insights.
Okay, so CS, do I click this checkbox or do I hit next?
Yes, so let's go to let's see what the results are. If you can pull this up. So I think just a quick request to everybody watching and taking part in this poll question. You can put it in the question box. If you're not able to input on the screen, you can just share your responses with us. I think we've got a lot of responses, so let's watch out perhaps for the social media on Siemens to see what the responses are, and then let's move on from there, John.
So there are different, there's different conversations around the metaverse, right? We've seen the metaverse for consumers, we've seen the metaverse for enterprises, and then now we're having a discussion around the industrial metaverse. And, you may have seen some of the headlines around the metaverse, right? And what that means. And so we want to kind of clear up what this is. So on the consumer metaverse, right, which, you've heard called spatial computing, you see a lot of demos of it online, where maybe people are viewing homes and so forth. What I'm talking about here is, this kind of evolution that's going on around the term metaverse. When we had the pandemic, everybody bought a camera, right? We were all jumping online. All of a sudden, living online became something that was the everyday. And so there's a lot of concepts like 3D computing power and AR and VR and 5G and digital twin. So there's all of these terms. They get kind of related to the metaverse, but what is it really? So that's what we want to define today. We want you to walk away with an understanding of what we at Siemens refer to as the industrial metaverse, not the consumer or the enterprise. This isn't Teams or Bitcoin. So what we had here is back in 2022, we started a conversation with the market, with all of us. And, we started it with Microsoft. We had a partnership with NVIDIA. And so we've really taken a deep investment in this space. And we've really started to work very diligently to change the narrative. And we've seen the results, because a year later, after 2022 and 23, you're starting to see the partners that we've got with Amazon and Microsoft and NVIDIA and TeamViewer. There's an incredible array of software providers like ourselves out there that have changed their vocabulary, and all of our consulting partners and so forth. So what we're seeing now is the needle is moving away from this sense of I've got to walk and live in this kind of space to understanding truly what is that industrial metaverse going forward. So it's here to stay. It's not going away. And, to be clear, it is not crypto or Fortnite or, any of these other incarnations that we've started to see emerge where there's an immersive environment, but it is in fact an environment that is around sustainability. It is all about driving, and you'll hear us say this again and again, a physics-informed digital twin, a true model, a physics-based modeling of the world we live in. And we're going to talk about that a little more, but it's something that will exist. And we're going to hit this again and again, from design through, the build, whether that builds on the factory floor or in the field, all the way through operations, workforce training. So, this is all about driving tangible results as well. This isn't just about, hey, I've got a great environment I get to walk and play in and so forth. There's tangible results because of an investment in an industrial metaverse around material, energy, productivity. We're going to be talking about reliability today. And for example, the grid, Ruan, we'll talk about that later with South Africa and Texas. So there are, if your focus isn't on results, then you're not, why make the investment? So that's why we want to talk about the power of this. So, this needs to be a collaborative experience, right? It needs to be something with high fidelity that provides excellent decision support. And that's what I think about a lot when I think about the industrial metaverse is, what is the decision support I'm receiving? Can I bring the entire team, whether it's people who are in logistics, personnel in the field, my project managers and program managers, my executives, my construction managers, if everybody is looking at the same level of complexity and visually navigating it, then that provides me a much better means to communicate. And, I come from a world of 30 plus years working all over the world in Romania and Mexico and China and Canada and every point in between. And the challenges we always had when you're working with these global teams is the ability to communicate effectively. And the best way to communicate is visually. And so when you have an environment like an industrial metaverse, yes, it becomes an incredible tool that provides high fidelity, in our case, photorealistic means to navigate complexity. And that's the other thing in energy. Right now, if you think about everything going on, and we're going to talk about this, the amount of investment we are making to transform our species and electrify the globe we live in is driving an incredible level of complexity. And if you're going to work through that complexity, the complexity of a chemical plant, a power plant, interprovincial pipelines, international pipelines, and so forth, when you think about what it takes to work through that complexity, it demands that we have an industrial metaverse going forward. And, we've been on this journey. We at Siemens and we as a species have been on this journey. I remember back in the 80s, just to date myself, when we started working with Autodesk and AutoCAD when it came out. We thought, oh my gosh, this is really cool. So, for many decades now, we've started with 2D design, which then led us to 3D modeling and digital mock-ups. It then led us to a 3D environment in which to do computational fluid dynamics and finite element analysis and 1D simulations. And so we've been on this path going forward of ever greater complexity, but ever great analytical abilities as a species. And now, as you can see from this, we're really entering into a time when the digital twin is now entered into our vocabulary. And executable digital twins have entered into our vocabulary. So on this journey, on this evolution, it's very natural that we're moving towards this industrial metaverse. And I want to keep stressing that. It's not just metaverse, it's the industrial metaverse going forward. Now, one of the things, CS, that you mentioned at the very beginning, why is it, when I talk about complexity and I talk about the challenges, just to put it in perspective, to your point, when you look at the total amount of data, just this is a proxy for the challenges we have as a species. You think about the fact that I can't even picture in my mind what a zettabyte is, let alone talk about it, right? But, by 2025, they're saying 181 zettabytes will be the total amount of data created, captured, copied, and consumed globally. So if you just think about, sometimes as a species, we can be our own worst enemy. We just create an incredible amount of data. So as we're doing this, we have to ask ourselves, great, but then how do I navigate it? How do I extract from this volume? And by proxy, think about what we're doing in energy, the ever increasing demand, regulatory demands and specifications and requirements from customers and just the sheer level of effort it takes to manage all that data. I'll give you another anecdote. So a colleague of mine out of Calgary, John Lusty, was working with one of our contractors that's a customer of ours. And that contractor, it's a very large EPC company, did a survey on a project they were on. This was about a decade ago. And they were on a 5-year project, $8 billion. And just to get a sense of the volume of disorder, if you will, they did a survey of all their contractors, all those contractors, subcontractors, all the different divisions of the customer they were serving on that project. They wanted to find out how many worksheets had been created that were being actively used throughout the duration of that 5-year project. And it was more than 400,000 worksheets were created during the course of that project. And that, I can't even get my head around that. But if you think about it, you've got thousands of personnel that come in and out of these projects over the course of many years. And, the default is always to create an Excel sheet to help get work done. So it's no wonder that you get this kind of disorder around data at a very high volume. And you ask yourself, why is it such a challenge to get your arms around it? Well, again, this is why we have to talk about a digital backbone. We have to talk about an industrial metaverse and what that can really mean for us to get our arms around the sheer volume of data just in our own world of energy. And the other thing that I'll point out too is what the other term that you hear our species using all the time now is artificial intelligence. I don't think there's a time when you wake up and look at the news online. I would have said newspaper to date myself, but nobody actually gets a newspaper. But if you look online at all the headlines, what's going on here about artificial intelligence? Well, again, what I want to stress is if you're going to be making investments in artificial intelligence, and everybody is, the artificial intelligence is only as intelligent as the data behind it, just as it is with humans, right? If I feed bad data to somebody, I'm going to get bad conclusions. So if we're going to make sure that future investments, the future adaptability of my systems is in place to be ready for deeper investments in artificial intelligence, I've got to make sure I've got my arms around the complexity and the taxonomies, the ontologies of the data, right? The relationships between the various data points, and understand the full life cycle. And we're going to talk a little bit more about that around all my varied assets. So if I ask artificial intelligence, what's the mean life to failure on this pump over here? Well, I better have a full life cycle of data behind that, as well as all the other data that's been analyzed around all the other similar pumps. And I need to be able to come up with a reliable conclusion from that artificial intelligence. That's just one example of a use case. So for me, getting control of this high volume of data, as complex as it is really what serves us for future investments, which the industrial metaverse is naturally driving a conversation around. And so, Ruan, we talk a lot about the we talk about the industrial metaverse, but we talk about the comprehensive digital twin, right? And so what do we mean by a comprehensive digital twin? And so there's a lot on this slide, and I'll let people kind of consume it, but it comes down to this. Can I clearly mimic with my digital twin the physical reality? And is that digital twin at all times in sync with the physical reality? So for example, if I send out a young engineer, the first thing you do when you hire a new engineer is you get them out in the field, because you learn by doing. So she's going to go out there with a ruggedized, intrinsically safe tablet, and we're going to start gathering data on assets, right? Maybe we go out and do an inspection. We look for holidays on coatings on spools of pipe or whatever. And so we're gathering that data. Well, as she's gathering that data, I need to ensure that the digital twin I'm creating from that data is in sync. So I don't need her going back to the construction trailer and rekeying and everything else. So no, I need an environment, an industrial metaverse, that's allowing me to take the digital twin to the workface, gather that data, bring that data back, so that anybody else that looks at the elephant of complexity and zeroes in on the work that she's done, or looks at the same spool of pipe and the same coatings, they've got the same story in the same time frame. So there's a level of investment here around data fidelity, data traceability, and ensuring that it's well orchestrated. Again, ask yourself, how well orchestrated is my data going forward? Because then that will tell you the value of your comprehensive digital twin, which is the heartbeat of the industrial metaverse. And I use this, Ruan, I use this kind of animation to kind of drive the point home. We don't have there's not enough room on the screen to actually show, work breakdown structures and advanced work planning packages and so forth. But as you're thinking through your business processes as an enterprise, right? As you go through and you define, like say, for example, the chemical plant or the power plant you're going to build, you've got to be able to carry that data forward into your detailed design. Right now, you're starting to develop variants on that plant. So you might have 3 or 4 different configurations. You need to run through those simulations. You also need to retain those simulations so that later on, when you get actual operational data, you can come back and continue to improve the model for the next build out, the next turnover, the next debottleneck, the next build. So it becomes a very powerful journey that we create here. So we've moved through define, we've moved through develop. Now we're planning construction. We're doing constructability reviews. We're doing HAZOPs. We're going through the process of actually thinking through and simulating the build out over time. And, if I skip forward, we're always designing for service, right? Making sure I've got enough spares and repairs for the long-term operations and maintenance of this facility. What I want to kind of come back to, though, is it's the build stage. And, too many times in my, again, 30 plus years of working all over the world, I've seen where failure to have a real life cycle, in this case, Ruan, people might ask the question, where do I get started? If you look at requirements, you look at specifications, you look at industry standards, and you look at those requirements around in design, and then the requirements for, the build out, the requirements for operations, that alone, if you can just get your arms around your global requirements, or if you're a young startup, get your arms around ensuring that you can demonstrate to a customer the efficacious alignment with requirements, throughout the process, this becomes a real challenge to carry all the way through. So when I think about the build stage or construction in my world, I begin to realize that all the problems we have in the field stems from the fact, most of the time, with a failure to be aligned to requirements. And we have to do a lot of rebuilds. We got to do a lot of tear outs. You know, the worst place to have problems is when you get to the field. And so when I think about the industrial metaverse, and subsequently I think about the comprehensive digital twin, I think about the work that you actually do and the requirements for said work and carrying it all the way through. I'll give you an example, and in fact, I'll wait on it actually because we're going to talk about it in the next slide. So this is, if you will, the full life cycle, right? Ask yourself, do you have the traceability step by step for your taxonomies, the relationships and the ontologies of that data along the way? Now, this is what I'd like to put up, because for me, in my background, it's great to say that we're going to develop a digital enterprise. It's great to say that we're going to get our arms around data management and do this well. But there's the everyday. And the everyday is I've sent somebody out with a torch to do some welding, right? I got a team out there and we're going to weld, we're going to hydro test, we're going to install. If it's a golden weld, then we'll go back and we might do ultrasonics and x-rays. So there's a lot of work that goes on just with welding. And I put this as a case. So one time I sat there in a job I had, and it was to be a weld inspector, quality assurance, and so forth. And I asked myself, how many documents potentially could be created around any one weld and the data points that go with that? And this is to drive the point home, CS, because when we talk about zettabytes, you're like, well, where's all this data coming from? Well, in one weld alone, you're looking at something like 200 to 300 original data points that you're creating just with that work. Weld procedures, certification of weld procedures, the hydro testing, all the post-weld heat treatments, the list goes on and on of activity around that, from both the welders, the material, managing the material, the inspections, the testing. So if one weld can generate hundreds of data points, how many welds are there in a plant? Thousands, tens of thousands, right? I mean, Ruan, go ahead.
What's really
Ruan, we can't quite hear you. There we go. We couldn't quite hear you there at first. Go ahead.
All good now?
Yeah, I can hear you now.
Yeah. John, so I think what's really important is we shouldn't just be thinking about the generation of data, because in many cases, you've got these processes dictated by organizations saying, oh, you need this, oh, you need this, and people do it as a formality. And what happens at the end of the day, John? At the end of the day, that goes straight into a storeroom. And that storeroom, please go and try do a control F in a storeroom. You're not going to be able to do that. You're not going to be able to get to that information in a good way. So really what we are trying to do is, I mean, you spoke about this, is that decision making. We need to take the information from the storeroom to the boardroom in the proverbial sense. And it doesn't always just matter or depend on if it's a physical document. You mentioned all of the spreadsheets. I mean, if there's no connectedness between those spreadsheets, I mean, what are you gaining? You are not. At the end of the day, yes, you're on a digital machine and you've got your laptop with you, but nobody else has visibility on that. And that is what's important, that connected nature of the information.
Well, and Ruan, as you're saying, storeroom to boardroom, what's interesting is even though we started with CAD back in the 80s, what's interesting is throughout my 3 decades of working in the field, I can't tell you the number of times we had to go back to legacy documentation, even today, where you have to be able to scan and extract symbology and work very diligently to pull that data out. So you're right, it's not just about generation of data, it really is just the holistic management of data, both generation as well as dealing with all of the legacy that we in energy still deal with. And, just because one part of the world might be super modern and up to date doesn't mean the entire globe is. And so that we as a species have this highly heterogeneous, state of maturity across the energy market and everything. So it's quite the challenge. You're right. But, when I look at something like just the simple act of welding, it could be bolt-ups on flanges. It could be, again, the most elegant, the simplest of procedures, and the amount of data, the volume that you generate is tremendous going forward. So just to, I have this right here. I put another slide in here to kind of drive the point home. So CS, think about this, right? We've got, by proxy, zettabytes of data that we're generating as a species. And, even the most, standard act of welding generates an incredible amount of data points. Now think about this. We've got the Energy Industries Council, tracks basically all the energy and chemicals related to said energy and power generation projects around the world. So you got energy, chemicals, and infrastructure here. And at any one time, every year what I do is I go through and I look at roughly about 5 to 8 years, where are we in the planning and the build out and the commissioning of all these capital deployments, these capital projects. And it's anywhere from 13 to 15 trillion dollars. I think last survey I did just a few days ago, it looks like this is bumped up significantly, even when I put this slide together. So we have trillions of dollars at risk as a species, generating zettabytes of data, all around us. And the most mundane act of just like inspecting bolt ups on these projects can generate, hundreds of data points. So it gets quite overwhelming if you think about it. But the beauty is, because of the investments we as a species are making in things like GPUs, from NVIDIA, our partner and so forth, we've now got the computational power at our disposal, especially on the cloud, to be able to manage this overwhelming sense of complexity that we have going forward. And, one of the things that, I have here on this slide, Ruan, and I want to just take a moment here. So we've got all this capital we're deploying. We've got this overwhelming amount of data that's coming at us. And it was kind of interesting. You made mention of this, or it kind of comes to mind as you're talking about it, which is when we think about the legacy infrastructure that we have around the world of energy. It reminds me of in 2021, when I lost all the lights for myself and all my neighbors, and basically about 95% of the state of Texas just went completely dark. And it took forever. I think it took something like 30 to 45 days before everybody's lights, quote unquote, were back on. And the fallout from that, there are people that died, the amount of impact to business. There's even articles from the Wall Street Journal about along the Gulf Coast crescent there of Texas, all the businesses that shut down. So you had polyethylene, polypropylene, PVC. You had all of these products that weren't being developed. And you don't just turn a chemical plant back on in 24 hours. It might take you, weeks or months to get a plant back online. So the fallout from something like this. So for me, the metaverse, the industrial metaverse, has to speak to how are we going to improve our lot in life as a species. And Ruan, I think you've experienced something like this in South Africa.
We coined it load shedding. So we were plagued and have been plagued by electricity outages for many years. And fortunately, it seems, at least at this point, that the team and the organization has made great strides, and we're on over 100 days without load shedding. But basically, what the team was trying to do, and what they are still continuously working tirelessly to do, is to get that stability in the grid. But this speaks to that legacy and, let's say, brownfields environments. And what we should also consider here, and I mean, obviously, I look after South Africa, Africa and the Middle East. In the Middle East, even though the challenges are a bit different, the solution at the end of the day is that both of these challenges can be solved with something like the industrial metaverse. If we think about stability in South Africa versus sustainability in the Middle East, all of those environments are geared towards having the industrial metaverse feed them with the correct information, and again, have that connected sense of information. Again, at the end of the day, we're talking about agile decision making, because that's where the efficiencies lie.
Yeah, absolutely. And I think we have a little bit of a survey here, CS.
Yes.
We're just curious. If people could take a moment to select, have you experienced any utilities related outages in the last 12 months, 2 years, 5 years? Because what this really gives a sense of is, if we're going to make these investments, what are the tangible benefits for us as a species, in my view, right? So we're spending trillions of dollars. We're driving to gather all this data. We're organizing it. We're creating these life cycles. So I have reliable investments in the metaverse and subsequently, artificial intelligence. But it better provide tangible results for us as a species on the ground. So there's a true challenge around the infrastructure going forward. And it looks like so people are making those submissions now. CS, do we want to wait until they're done here, or can we move forward? No, we have to wait.
Yeah, I think we'll just give maybe a few more seconds, a few more, let's say a minute.
Right.
We encourage everyone, all those who are watching live, please do choose one of the options that you can see on your screen and let us know. So we'll just quickly analyze. John and Ruan will analyze the results for you as well.
Yeah. So Ruan, while people are doing this, one of the things that comes to mind is, and it was just this summer, so we had a bit of a storm, tropical storm come through Houston, Texas. I know people ask the question, why do you live in Houston, Texas if you keep having hurricanes and storms? But hey, it's a beautiful place to live. But we had a bit of a tropical storm in the month of June, and we lost power again for a week. And then it kept dragging on and dragging on. And so, the reason why this is such a focus for me is, if we're going to be driving digital solutions, and you think about what we have as legacy infrastructure, we better make sure that the two come together to be able to provide results around this. And it's a good proxy. You think about chemical plants, you think about power plants, you think about unscheduled outages, you think about the challenges around turnarounds. So anytime you're taking things offline and you're having to plan through it, the higher fidelity, the better the data details, the better the life cycle around it, the more reliable that it is, the better your performance, the better for our species going forward. So at this point, I'm going to go ahead, CS, and keep moving on and everything, if that's okay. It looks like we've got, look at this. In the last 12 months, 40%? So, I mean, we're all experiencing this, right? We're all dealing with the crushing demand on this grid. I mean, think about this. Who would have thought that, in fact, look at the headlines that have been going on. So Microsoft is now working to turn 3 Mile Island back on. You've got Google with a headline that says they're now going to work to install 7 new nuclear plants. So I'm actually up here at Fusion Power in Seattle, and there's this tremendous effort around advanced nuclear going on globally. And so why? Because 10 years ago, would we have predicted that artificial intelligence and data centers and all the demands that the industrial metaverse is making on the internet, right, on the cloud, would that have been such a hog for power? So think about this. We've got our legacy systems which are failing us. We've got these incredible demands for ever increasing volumes of power, supply of power. And so it's all coming together. So, and our mindset here, Ruan, that you and I share is, the data behind that, the work behind that to design new infrastructure on top of old and keep the old, still functioning and going forward. That sheer demand, that level of fidelity that's required around that complexity can be almost overwhelming. So here's what I want to do, Ruan. I want to take a moment to kind of, it's one thing to talk about this, it's another thing to show it, right? And so whether we're talking about products or whether we're talking about production at plants, there is this ability to drive comprehensive design, a comprehensive digital twin with, detailed design, physics-informed simulations, and so forth going forward. And so we've got this video here. Let me see if I can get it started. That shows, let me see if that pops up. It should. Yes. So you should see now, this is one example of 2 or 3 that we're going to show here. So as we're going through this and you're looking at this video, this is not technical marketing. This is actually our tools in action, right? This is a photorealistic, high fidelity design and simulation of a pleasure watercraft, for one of our customers going forward. It becomes when we talk about the industrial metaverse now, as a proxy, this demonstrates to you the very clear advantages we have if we've got a very powerful life cycle, of data management and a strong data backbone behind these designs that carry forward into the simulation, and now provide you the confidence that as you're moving through to actually produce this, imagine how you can lower the cost structure around something like this, where I'm not having to build out endless physical prototypes to get to the final result, but I've actually got this very detailed computational fluid dynamics and finite element analysis, this very powerful simulation environment. And, that's on the product side. But then when you look on the plant side, right, it becomes a very powerful opportunity of working with an industrial metaverse in a civil structural environment, right? Now, this is the world I come from, right? This is the world where I want to be able to go in and look at a structure in high fidelity and be able to rely upon the results. And in this case, we're demonstrating not only the complete structure for one of our clients, Freyr, that we developed this entire capability for, but then within these structures, what are all the processes on the factory floor? Right? What is going, and think about this, the very, let's say from the very large to the very small. So, we look at the entire campus, we look at the entire structure, but we can literally zero down in on the threads of the bolts, on the flanges, on the spools of pipe. That's the kind of details that you get into where you can really drive scenario analysis and failure mode analysis going forward, because we now have the computational power we always dreamed of as engineers is now at our fingertips. I mean, look at this from a human-machine interface perspective, the kind of safety and HAZOPs that we can do, whether it's on the factory floor or in the field. So it's a very, very powerful environment that we have at our fingertips. So to kind of bring it home, if you will, there's digital data that you're creating, but there's also the real data. All right, so let's talk about that just for a second, Rohan. We've had conversations about, the brownfield. So the term of art in our industry, a lot of times is we talk about greenfield, brownfield. So you've got greenfield, new business, new construction, brownfield, existing structures that I want to, advance or debottleneck, continue to maintain and operate. I may do expansions on them, so I have some greenfield associated with the brownfield. So when you think about brownfield, you think about point cloud scans, you think about photogrammetry and so forth. So the industrial metaverse is not just about new design, but it's also about the brownfield existing structures and the ability to bring all of that together for a comprehensive digital twin. And I'll just do a call out that right now at the University of Texas Process Science and Technology Center, which is a full-scale, fully operational chemical plant on the west side of the University of Texas campus in Austin, Texas. It's the only university I know that has a fully operational chemical plant. It was built by Dow Corporation in 1985, and we're members of the Process Science and Technology Center at Siemens. And right now, we've gone out there to scan the entire facility, and we're doing just that right now. We're reverse engineering the entire facility into our design product index. We're rebuilding a data backbone and a taxonomy, a plant breakdown structure for that plant within Team Center. And we are fleshing this out so that we can turn this into not only a wonderful, incredible physical experience for students and members of the Process Science and Technology Center to use as a test bed, but we're also going to build its digital twin and develop a digital makerspace in association with this physical plant. So I get real excited about the fact that you take digital data, you've got the reality in front of you, you've got the digital twin in sync with the physical reality, and you've got this true physics-informed digital twin that is at the heart of the industrial metaverse. And it's powered by the partnership of NVIDIA, Siemens, Microsoft, and the many other, Amazon, and all the other partners we show here. So it's not the art of the possible anymore, ladies and gentlemen. It is, in fact, actually what we're doing today. And we were able to show you that in those videos. In fact, at the end here, I included a quick snapshot of what we're reverse engineering at the University of Texas campus. So Ruan, we've had, quite a journey as a species over the last several decades. We've always been hoping we would get that computational power necessary to realize what we could conceive. Well, now what we could perceive and conceive is now becoming a reality for us in the everyday. And I'm really excited about what we're able to showcase today. And I hope that people understand, when you say metaverse and you say virtual reality, and you think goggles and all this kind of thing, that's not what we're talking about. We're talking about the design, the simulation, the build, the walk down, the commissioning, the startup, the operations, the maintenance, and then come back full circle to bottlenecking or doing turnarounds. And again, planning, building, commissioning, starting up, and making sure that you've got a taxonomy. It might be a bill of materials from a factory floor. Like, for example, in advanced nuclear, we've got bills of material on the factory floor around these nuclear devices, right, that are like small modular reactors. And we have to translate that into work packages in the field, which become installation work packages, which then become commissioning walk-down packages, which become check sheets, which then become a commissioned plant that's now operating and started up. But now we have to be able to flip that to become a plant breakdown structure. So you have all these varying taxonomies about the same data from different personas. We have that from manufacturing, and it's our product team center that we developed that created this very powerful environment to capture this structure, but then be able, based on the persona, to reorganize it so that people get value out of it, but they're still seeing that same elephant of complexity as we go forward. Ruan, what are your final thoughts?
Yeah, I think this is it's always so great to see what we have to offer, even from putting my Siemens hat on. And I think one of the things that's coming out and that I really want to emphasize, one of those key takeaways, and you mentioned this around AI, and that is that data, that we are generating an obscene amount of information, and we need to be able to effectively leverage that. One of the things that we can sometimes think, John, I think that a very fortunate thing is that we are in two quite different regions at this point. One of these days, you'll obviously be visiting us. Fantastic. But I think we are not just talking, it's not John speaking from the context of the USA. It's John speaking from the context of energy and all of the things that we are currently seeing that's happening in the Middle East. The Middle East is a strategic focus for us because the organizations there have made the decision to be more digital, to be more efficient, and to be more effective. And that is the thing. That's what we are trying to drive here, is that level of efficiency that we feel is at our fingertips already.
Yeah, thanks for saying that, Ruan. Just to be clear, as I lead global strategy, and if you're in the automotive business, it means that you're in Japan, Detroit, or Germany. If you're in the energy business, you better be in the Middle East. And so, I've made a deep commitment to making sure that we drive innovation and support growth and support the advancement of the energy infrastructure of the Middle East going forward. And that's why I'm so excited about going to ADIPEC, and I go every year, because it's this incredible crush of humanity around the energy, the entire global energy landscape. It's a once a year opportunity to just get in front of everybody. And ADIPEC is ground zero for us to look at, energy innovations, data management, driving, these innovations in our energy space. And anybody and everybody that's in energy shows up there. So I can't wait to get there. And I'll be there the week before and the week after. A lot of customers to meet with, a lot of work to do, because we're going to make that. We've made the commitment and we're driving it in the Middle East. So Ruan, thanks for that clarification. CS?
Yes, absolutely. And it'll be fantastic to, I think, see all of you there at ADIPEC, the world's largest energy event where the whole energy industry and the ecosystem convenes and way beyond. It connects really well to all the themes that you dwelt on for the last half an hour, 45 minutes. And surely, John and Ruan, thank you very much for this presentation. It's a very, very enticing invitation, I would say, to join the world of industrial metaverse. But I had a question, which I'm sure like many of the viewers and those who are watching us today would like to ask as well, that the transition to an industrial metaverse model might not always be very smooth. There might be challenges. How does Siemens help with that? And how can companies experience the industrial metaverse with Siemens?
Ruan, I'll let you get started with that.
Yeah, I think what's really important is that the way that we are gearing ourselves up to this is not from, oh, we think there's potential here, let's quickly put something together and take it to the market. That's not the idea at all. The things that we are basing our let's say proposal on are things that are very mature and things that have been developed and worked alongside with Siemens and technology partners through multiple years. It's not something that's new, as John said. This is a journey that we've been on for many years. Yes, in some instances, I mean, we've got a very large footprint when we consider something like automotive, but the types of problems that we see the energy industry is currently facing is very analogous to that was faced 10 years, 15 years ago by the automotive. And we are getting into that space now where we can bring our historical learning and not just be a solution or technology provider, but also be a business partner to these organizations.
Yeah, 100%. And you make a good point, Rohan. And it's been my observation that the energy industry has been generally about 15 to 20 years behind manufacturing when it comes to the kind of innovations. And we're at that point now. So the lessons learned of digital manufacturing, advanced manufacturing, and the digital that goes hand in glove with that has now made its way over here. In fact, many years ago when I first joined in 2016, I joined Siemens. Just prior to that, the reason why I wanted to join Siemens was I was looking at the solutions we had in manufacturing from Siemens and trying to translate and drive its applicability for us in energy. And I'm happy to say that the product lifecycle management that we saw in manufacturing has now become capital asset lifecycle management for us here at Siemens and in partnership with our customers. Now, I noticed in the Q&A, CS, I kind of peeked in there really quick. I think somebody said something about working with owner operators and so forth. We've got some very large marquee customers we'd be happy to discuss with you face to face that we work with, where they've standardized, for example, their global requirements for all of their capital projects on our products. And again, that's where they started, was with requirements management. We have other companies we have one in particular in the Middle East that we work with, very large LNG producer, where we're taking legacy documents and we're scanning, extracting symbology in the data and building up, a solid taxonomy and data backbone for this company and to transform them into an incredible digital enterprise going forward. So CS, over to you.
Thank you. I just wanted to also explain and then go over some of the words that we got as a feedback. Remember that when we asked the first poll question that, what are some of the words? So let me read it out and then let me know your thoughts. So digitalization, virtual worlds, and I think this one particularly, John, in light of what you said about the data problem, a complex world of data.
Yeah, absolutely. I mean, so, when it's interesting, somebody said virtual worlds. And so 100%, if all, that's what when I first heard the word metaverse, that's what I'm thinking about, right? I'm thinking about there's something very virtual. For me, though, and this is just me speaking, right, as John Nixon, when I hear the word virtual, it almost feels kind of intangible, right? It almost feels like something I really can't touch, and it seems a bit ethereal and so forth. And so I want to move away from the term virtual, which is a correct, whoever wrote that, you're right. That's kind of the sense you get from everything else we're bombarded with around us. And I want you and I and the rest of us on this call to kind of zero in on something that's the tangible, right? The everyday. So CS, when you mentioned that comment about data, it's a complex world of data, but it doesn't have to be one that's overwhelming. And we don't have to continue to fail as a species to deliver on time, on budget. Think about, the headlines you see around interest rates and the level of taxes and tariffs and the inflation rate that's going on globally everywhere that we see, and the challenge that makes for us in securing capital for these projects and in burning through that capital as we drive through the execution of these projects. For me, the data, I'll tell you, there's a term I like to use, and I want you all to think about this on the call. All right, so listen up. If you hear anything, listen to this. Ask yourself, is your investments for data, driving a model-based financial optimization for your company, MBFO. Take that, own that term. Are you driving model-based financial optimization? And I'll tell you where that comes from. So model-based systems engineering is where I see right now the energy industry is moving ever closer to. So you've got multi-disciplines. If you think about that slide where I showed, design and develop and the build out and so forth, that plan and build out, that whole kind of legacy of stage gate, as you're going through that, there's a fidelity of data that now brings all disciplines together, your various engineering disciplines, your construction disciplines and so forth, your technicians in the field, all the data that's being created and coming together. And you're developing this model-based approach, a systemic approach to how we engineer and how we build. So what I take it a step further. And when I bring the supply chain, ERP is brought into the metaverse, your enterprise asset management is brought into the metaverse. When all of this comes together, right, now you have not only the reliability and the productivity that you can measure, but now you have the financial, profitability that you're going to bring into this. So your industrial metaverse and the data backbone that you create is going to pull in a lot more than just engineering data. It's all the federated data around the enterprise that all apply to these assets that we have operating in the field that are generating revenue for our company. So ask yourself, do you have an approach to model-based financial optimization, which at the heart of it has a systems approach, which means, again, you've got to have a comprehensive digital twin, which means, again, that you've got to have a detailed data backbone that's well orchestrated and traceable. CS?
We'll go through some of our audience questions. We've got some very, very interesting questions. I think a bunch of questions center around broadly this theme that many companies are still trying to implement Industry 3.0 and not even 4.0. So what is the best starting point to start moving towards the industrial metaverse?
Okay, you know what, Ruan, I was thinking that we might get questions like this. I'm going to skip ahead. You know what? I've got some bonus slides. So here we go. I'm going to skip past the video. We'll come back to this in a moment, CS, to this slide. I'm going to stop the video here. I'm going to come back to this video. It was a bonus video and everything. Actually, I'll tell you what. I'll let this play a little bit. So everybody take a look at this. So some of you may have already seen this. Just again, this was kind of a little bonus video at the end, but I'm going to come back to that question in a moment, CS. But again, this isn't technical marketing. We've actually done this with Hyundai. We've actually stripped away the whole, we can get to this level of detail around these systems and systems of systems, superimposing the simulation and so forth. It becomes such an incredible decision support capability when you've got this level. So let me skip past that. So you should be able to see my screen here. So when we think about this, here's what I want, to answer that question. I want people to consider where we are, right? You mentioned Industry 3.0, or, because again, these are terms du jour that we put out there, Industry 3.0, Industry 4.0, and so forth. I come down to, the current state is we've all made investments, right? We've all purchased ERP systems and EAM systems and, CRM systems, and all these abbreviations and acronyms go on and on and on. So, and we've got SCADA systems. I mean, so there's no shortage of investment in energy in digital solutions. The problem is they're all generating all of their own complexity of data. Everything is a bit siloed. It's a human-centric effort to bring all of the data together and to then be able to start drawing forensically conclusions from all of that data. So it's overwhelming. So in anticipation of kind of having this kind of conversation, if we can set aside Industry 3.0 and 4.0, let's look at it in terms of a journey. And I put some details here. And hey, everybody, feel free to screenshot if you like. But this is in fact where my mind is at, and what I hear from our customers and what I see going on in the market. When you think about, if we start first with how do I get this systems engineering approach? Well, I've got to be able to build a powerful enterprise data architecture. That's what I need to do. And then below, I talk about how I won't read through all of this because there's a lot of words here, and you can go through it later. But essentially, let's configure and create and set up a well-orchestrated, traceable data backbone first. And then on top of that, Now I can perform all the design work, the simulation work, and everything. Now, more importantly, or just as important, all the investments you've made, right? We've got to have an open ecosystem. And Ruan, we talk about this a lot about interoperability. If you're a legacy energy company in the Middle East, for example, in the case of our audience here, where we're talking about ADAPEC, you have to ask yourself, well, I've got SAP as a backbone, or I've got IBM Maximo, or I've got Salesforce, that I'm using. Well, guess what? We're fully integrated to all of that. We know that if you're going to want to build and drive a true data backbone for a digital enterprise, you have to have that kind of interoperability. A good colleague of mine, Eric Brozis, who came with TSYS, which was a company that joined the Siemens family years ago, the whole point of it was he had built a company and had driven this vision of seamless, frictionless interoperability between a data nexus, if you will, and everything that you've invested in. So we've made those investments in expectation of that. And then when you start to get into AI, you know what? A colleague of mine, Todd Huthill, who runs our global aerospace strategy, he showed me a white paper that came out of one of his colleagues in the aerospace industry, in which they talked about automating the mundane. And that really I was like, I love that. That's perfect. And that's what you do. You start to ask yourself, like, great, I've got a very powerful data backbone. I'm integrated and interoperable with all the different federated sources of data. So when I have an asset that I have found, I'm getting some cavitation or vibration, or, like my world that I come from, I'm starting to see holidays on the coating, so I'm going to have to go back and grind out and recoat the pipe and things like that. You know what? Why don't you automate the mundane, the work orders that get generated when inspections are done and problems are found. So we start to automate the mundane. We start to drive artificial intelligence at the lowest level, and then we build up over time. And then we get into generative engineering. We purchased a company called CD Adapco, which has a product called HEATS, which allows you to wire together all your different sources of data and run innumerable models and simulations around it and get a generative approach, right? A design space exploration, if you will. And you can actually also wire in financial modeling to that, so you can start to explore various financial models, various supply chain modeling around availability for spares and repairs and the work to be performed. Think about that on turnarounds. Think about the ability to do powerful scenario analysis on not just one or two different scenarios for a turnaround, but on 1,000 or 2,000 in the same time frame. That's the kind of power that we have around AI. So rather than Industry 3.0 and 4.0, take a step back and just say, where am I on configure, connect, automate, generate, and optimize? Where am I at in my journey today as a digital enterprise, if that makes sense? So CS, that's kind of my answer to that question.
That's an excellent point, John. And I think that also sort of answers, we got some similar threads around how industrial metaverse can also support in the field of construction for the energy sector. And I think that's right. Sort of goes back there as well. One more very interesting question that we've got is, what role will the industrial metaverse play in training and upskilling the workforce in the energy sector, particularly for complex and hazardous tasks?
Oh, I have an answer for that, but Ruan, I'll put you on the spot here in the last minute of our webinar. What are your thoughts on workforce development?
Yeah, I mean, as you kicked us off today, John, work visually. So in the past, it was definitely a more tricky situation, especially if it's a hazardous environment. How do you efficiently and effectively train someone on something if they haven't been in that scenario? And obviously, that's not something you can't just quickly go wire up a boardroom to simulate that type of environment. So what do? You give them access to the industrial metaverse, John, and that is it. And that is it. And you take them through those processes. They get real world, well, as real as it gets, right? I mean, right. You spoke about virtual world and so on. This is as close to the real world as you're going to get. And that gives you that.
Yeah, no, I'm sorry, not to interrupt, but you mentioned work visually. I love that. That is, and you know whose motto that is? There's a company out of Calgary called Verum, V-E-R-U-M, and they're a partner of ours. And in fact, that scan you saw earlier, CS, of that chemical facility, that came out of their product. And we work very closely with Verum going forward. And it's funny that you say work visually, Ruan, because That's how you kind of zero in on, issues in the field, or, it's not always the negative, right? But, what are we doing right? What are we doing wrong? And the fidelity around that kind of scenario analysis, failure mechanism analysis and so forth, that is now capable and possible given this emerging complexity. And in workforce development, it's not just about putting goggles down, right? It's about being able to take people through. And by the way, that's such a great question, and it explodes all kind of use cases around, the fidelity you need. Like, for example, you've got, crews that come in on rotation. Well, what's changed since the last time that I've had, since they've been there? And having the ability, almost like with X-ray vision, to be able to visually navigate through the facility and understand what's changed, where are there new hazards, tripping, falling, banging your head, new compressed gas cylinders are now installed over here. And, the use cases go on and on and on. I very much think about the everyday in technicians' lives, that having this kind of industrial metaverse, not just, again, with goggles on, but being able to walk people through a visual navigation of that complexity and make sure that we are not only working visually, we're communicating visually. CS, I think we're at time here.
Yes, thank you so much, John, and thank you so much, Ruan, for that fantastic overview. And we've just run out of time, absolutely. And thank you so much for your insights and this very exciting invitation to join the world of industrial metaverse. I hope our audience has gained a lot of insights into how we can optimize and sort of develop in terms of the energy sector. You can book a meeting with Siemens using the QR code that you see on your screen here. You can feel free to take a screenshot. And a big thank you to all of our audience for your excellent questions, for your active participation in the polls, and look forward to meeting you, all of you, at ADIPEC.
And CS, with all the questions that we had, we'll be able to follow up with people after this, correct? Because we've got I see we have a long list of questions here.
Absolutely, we have a very long list of questions, and sure, we can make sure that we are able to follow up with those questions. Thank you so much, John, and thank you, Ruan, for your insights.
Phenomenal. Thanks for hosting us. And Ruan, I'll see you in the Middle East here in a couple of weeks.
Thank you. Thank you, everyone, for watching. And you can always follow energyconnects.com for comprehensive coverage of the energy industry. Don't forget to follow us on social media. Thank you.
Have a wonderful day.